Taiwan is increasingly transforming into one of the global centers of robotics. And in these mega factories, not just manipulators are being created, but fully AI-integrated next-generation collaborative robots, cobots. Unlike traditional industrial arms that operate in isolated zones, modern cobots are designed for direct interaction with humans. They are equipped with computer vision systems, LiDAR sensors, torque sensors, and machine learning algorithms that allow them to adapt to changing environments in real time. At such factories, each robotic arm can perform assembly with precision down to tenths of a millimeter, and thanks to AI, the system independently optimizes motion trajectories, reducing wear and energy consumption. Productivity increases by tens of %, while defect rates drop to minimal levels. Some platforms are capable of operating 24/7, analyzing data from thousands of operations and continuously learning from their own experience. The key factor is modularity and open architecture. Manufacturers provide APIs and tools for integration into any production line, from electronics and semiconductors to the automotive industry. This is why Taiwanese factories are becoming a strategic element of global supply chains. Microelectronics, AI, and high-precision mechanics converge here. In fact, we are witnessing a transition to a new type of factory, where humans are not replaced, but augmented by technology. And if the pace continues, such AI cobots will become the industrial standard within the next few years. Unitry Robotics continues to shock the world with the capabilities of its robots. Against the backdrop of the Temple of Heaven in Beijing, something that just a few years ago seemed like science fiction is taking place. Dozens of Unitry G1 humanoid robots are synchronously performing kung fu elements. This is not just a show, but a demonstration of a new level of coordination and balance. Each robot is equipped with high-precision servo drives delivering torque up to hundreds of Newton meters, a real-time stabilization system, and a sensor suite, LiDAR, inertial modules, and cameras for spatial orientation. With a height of about 1.2 to 1.3 meters and a weight of around 35 kilograms, the G1 is capable of sharp turns, low stances, kicks, and dynamic movements without losing balance. Control is based on machine learning algorithms that allow the robots to act synchronously as a single cluster, essentially like a humanoid swarm. Such demonstrations are not merely cultural performances, but testing of future scenarios, from rescue operations to work in hazardous environments. China is clearly showing that humanoid robotics is leaving the laboratory and beginning to move like a living being. However, Unitry Robotics can boast more than just humanoid robots. Introducing the Unitry A2, a next-generation compact robot dog that combines industrial power and mobility in a small body. Despite its size, it delivers torque up to 90 Newton meters, allowing it to confidently traverse uneven terrain, climb stairs, and operate in challenging conditions. With a payload capacity of up to 15 kilograms, the A2 can carry equipment, cameras, sensors, manipulators, or industrial tools. Its operating time exceeds 4 hours without payload, and its travel range is over 13 kilometers, making it a fully capable mobile platform for inspections and monitoring. The body is protected to the IP54 standard. The robot is resistant to dust and rain, meaning it can operate on construction sites, in industrial zones, or in outdoor environments. Performance is stated to be approximately 2 times higher than the previous generation Unitry Go 2, and its open architecture allows companies to develop their own modules and application scenarios. In essence, the A2 is not just a robot pet, but a universal industrial tool that is gradually bringing robotics into real business. In the mountains and on challenging agricultural land, a new assistant is emerging, the Lynx M20 robot dog from Deep Robotics. This is not just a technology demonstration, but a real solution to the so-called last-mile problem in rural logistics. Where machinery cannot pass and people have to carry harvests manually, autonomous quadrupeds step in. The Lynx M20 can transport crates of produce along narrow paths, concrete channels, and uneven ground, maintaining stability even on slopes. Its stabilization system analyzes the surface in real time, and intelligent navigation enables it to follow routes without constant operator supervision. The robot can operate for hours, reducing the physical strain on farmers and accelerating the harvesting process. Such platforms represent a step toward the digitalization of agriculture, where AI and mobile robots become part of everyday operations. And if previously a robot dog was associated with laboratories, now it is a full-fledged participant in the agricultural economy of the future. This is an experimental sprawled-type quadruped trained to walk over complex terrain using reinforcement learning algorithms. Unlike pre-programmed movements, here the robot literally learns to move on its own. A neural network analyzes thousands of attempts, evaluates stability, slippage, and surface inclination, and gradually optimizes its gait. On the test platform, the robot confidently adapts to changes in slope, from 5 to 10 degrees, automatically redistributing load across its legs and shifting its center of gravity. Torque sensors, inertial modules, and surface contact sensors operate in conjunction with an AI controller that adjusts every step in real time. This technology is critically important for movement across rough terrain, from mountain trails to post-disaster debris. In the future, such algorithms will allow robots to move autonomously where humans risk their lives. This is no longer just mechanics. It is a step toward truly adaptive robotics, where a machine learns to interact with the world almost like a living being. In New York, an unusual municipal worker has taken to the streets, a shovel-equipped robot from Reflex Robotics. This is not just a marketing stunt, but a demonstration of how humanoid machines are beginning to perform real urban tasks. The robot is mounted on a wheeled platform for stability, and its manipulators are equipped with force sensors and computer vision systems. It does not simply move a shovel. AI algorithms analyze the shape of the snowdrift, calculate the angle of approach, and determine the snow throw trajectory. The machine navigates its surroundings, recognizes sidewalk boundaries and obstacles, and then methodically clears the area, almost like a human. Such solutions can operate in harsh weather conditions, reducing the burden on municipal services and addressing labor shortages during the winter season. This is not yet a mass replacement of people, but already a step toward autonomous urban infrastructure, where robots take on heavy and routine work. Before you is the Yamaha Motoroid, not just an electric motorcycle, but an experimental AI bike that can literally stand upright on its own. Thanks to its active stabilization system, gyroscopic sensors, and intelligent controller, the bike maintains balance without a rider and can lift itself from a tilted position. At its core is a suite of position sensors, inertial modules, and machine learning algorithms that analyze the center of gravity and instantly adjust the lean angle. The electric drive responds in fractions of a second, redistributing torque to maintain stability. This is no longer just a vehicle, but a robotic platform on two wheels. If such systems reach mass production, two-wheeled transport could change dramatically, becoming safer, smarter, and almost self-sufficient. Write in the comments what you liked the most after watching this video. Subscribe to the Karo Show channel so you don't miss the next episodes. Bye for now.